Hey guys, this is Miss Middleton. I just wanted to go over humidity with you since that's what we're talking about today. Some of this we've covered yesterday, such as humidity, which is measuring the water or the H2O in the air. Specific humidity or absolute humidity, we talked about this in your lab yesterday. So it's the actual amount of water in the air. Absolute humidity is kind of like if you could weigh the air and weigh how much water was in the air. That would be what absolute humidity is. So it tells the number of grams of water in 1 kilogram of air. So for example, 15 grams per kilogram, that would be 15 grams of water in 1 kilogram of air. And I already added this into this image. You need to add this in. So you have this chunk of air. They call it a parcel. Parcel is like an old-timey word for an Amazon package. But so you have a box pretty much of air, and that's 1 kilogram. And then inside of it, it has these little droplets, and those are weighed, and there's 15 grams in this chunk of air. Okay, so let's save that. If you missed that, you can go back and pause it. I know I'm going quick. But anyway, relative humidity, this we also looked at yesterday, is the amount of water in the air divided by the maximum amount of water it can hold. So if you remember yesterday, we had the example of it had pictures of sponges, and one sponge was really small. So if it's a cold chunk of air, it might be small, but it can't hold as much water because it's smaller. So it'll fill up faster. All right. Versus a really warm chunk of air, it's a lot bigger, can hold more water. Okay. So for example, air is holding 15 grams per kilogram. It actually can hold 20 grams per kilogram. So if I take how much it actually is holding divided by how much it actually can hold, let me get my calculator. If it wasn't so slow, here we go. So you would take 15 divided by 20 equals times 100. So the relative humidity for that chunk of air would be 75%. Okay. When the air is holding as much water as it can, we say that air is saturated. And in that case, the relative humidity is at 100%. The air cannot hold any more. It's 100% full. Relative humidity changes with temperature. All right. That's a big deal. Just like I said with the sponges, the same is true with air. Did I do that right? Yeah. Okay. Because warm air can hold more water vapor. So, for example, this air or this red balloon is an example of air, and it's at -5 degrees Celsius. It's pretty cold. You'll notice the water for each of these, which is the blue balloon, stays the same. So the water doesn't change, but you can see as we heat up these balloons, they get bigger. Now, when it's cold, the air can't hold as much water, and it's almost completely full. You can see just a sliver of the air, the red air there, but the water is almost taking up the whole space. So that air is very close to saturation. It's at 98% relative humidity. As it heats up, the air expands and can hold more water. And you'll notice the percentage of how full this air is of water lowers. It's only 10 degrees or 10% relative humidity. So this air is very dry, okay? Now, dew point is another way we can talk about humidity. Dew point we also talked about in our lab yesterday, where it's the temperature you have to cool the air to get a cloud. All right, so look at the comment below and try to come up with your own definition of dew point. in the actual class, we will stop and take some time and you guys will come up with an example. But if you're watching this because you got kicked out of Google Meet or you were absent, that's fine. You can see here, the air is saying we're almost there. And the temperature, the regular temperature is 53. The dew point is 51. Here it gets cooler, right? Temperature is 52. It's dew point's still 51. They're getting closer together. Ready? And then once those temperatures are the same, condensation can happen. There's little rain droplet. Let's do it. If you suck at spelling, that do is spelled incorrectly. Okay? So, well, for the grammar that you're going for. For the joke, it's perfect. Okay? Your definition, when temperature and dew point are equal, condensation can happen. So, dew point is the temperature the air needs to cool to in order to form a cloud. Woo! Got it. All right. Dew point is the temperature at which air becomes saturated. All right. So when the air temperature reaches dew point temperature, relative humidity is going to be 100%. It's going to become saturated. The temperature, air would have to cool to make a cloud. We just said that. Boom. And the water vapor in the air condenses at the dew point, okay? So let me go back here and check my example. Boop, boop. All right, so if you have a glass, so a glass of cold, if you are drinking a glass of cold water and sitting outside on a hot, humid day, so that's lots of water in the air. If the air, your glass will appear to sweat. What's really happening is the air that has water in it around your glass touches the cool glass, cools down, cools down, condenses, and can't hold the same amount of water. So it condenses on the outside. It kind of like spits out that extra water that suddenly it can't hold because the air is too small to hold it. That is dew point. All right, those are the notes we're going to go over today. And I hope you have a great day. Bye. Maybe. Hold on. Got to click this little button. All right, for real, have a great day.